back to edupediaword.com, your destination to free online education. In this video, we will be discussing the topic conversion of solids from one shape to another with the help of some questions. Friends, the first question says a metallic sphere of radius 1.5 cm is melted and recast into the shape of a cylinder of radius 4 cm. Find the height of cylinder. So friends, we originally had a sphere with radius 1.5 cm and we have converted it into a cylinder of radius 4 centimeters. We want to know the height of this new cylinder. Friends, when we recast a shape or a solid into some other solid, then no doubt its shape changes, but the amount of the metal or some other thing that is being used in both the shapes will be same. That is, volume remains constant ideally when we convert one shape into another. So friends, volume of a sphere is given by 4 by 3 pi r cube. Cubic units, where r is the radius, and volume of a cylinder is given by pi r square h, where r is the radius and h is its height. So we know that volume remains constant during the conversion process, so this volume will be equal to this volume of the cylinder. Thus, by simply substituting different values, we can find out the height, that is 4 by 3 pi r cube, where this small r is the radius of sphere, divided by pi r square is equal to h, the height of cylinder, where capital R is the radius of cylinder. So this pi will get cancelled and we have 4 by 3 1.5 cube over 4 square equal to h. That is, h will be 4 by 3 into 16 in the denominator and 1.5 into 1.5 into 1.5. On solving this value, the height will come out to be 0.28 centimeters. So in this way, this problem will be dealt with. Now, in the second question, it is said that a cylindrical bucket, which is 36 centimeter high, that is, its height is 36 centimeter and radius of base is 12 centimeter. Since it is a cylindrical bucket, so the radius will be uniform, that is, radius of top will also be 12 centimeters, is filled with the sand. So this bucket is filled with sand. The bucket is emptied on the ground and a conical heap of sand is formed. So this material, that is sand, is used to form this conical heap on the ground. If the height of conical heap is 16 centimeters, find the radius and slant height of the heap. So friends, as discussed in the previous question, the volume of material used in this sand inside the bucket and used in this conical heap formation is same. So we can say that volume of conical heap is equal to volume of cylindrical bucket or the sand inside, because this bucket is filled with sand, so we can say volume of cylinder also. Now volume of conical heap is 1 by 3 pi r square h, where r and h are the height and radius of cone, whereas for cylinder we know that its volume is pi r square h. To distinguish between two radius and the heights, we are using small r and h here and capital R and h here. So the height of conical heap is 16 and we have 1 by 3 pi r square, whereas here we have radius as 12 centimeters and height as 36. So radius can be calculated by simple mathematics and it will give us pi will get cancelled and this 12 can be written in 12 into 12 because of the square. Sorry, it is 16 only, so we will get ultimately r square as 972, and on solving this square the radius will come out to be 18 under root 3 centimeters. So we need to calculate the radius as well as slant height of the heap. Radius we have calculated as 18 root 3 centimeters, whereas the slant height, that is this height, can be calculated by using Pythagoras theorem. Considering the cone as an ideal regular cone, we can say that this angle is 90 degree, and by Pythagoras theorem L will be under root r square plus h square, that is r square is 972 and h square, because h is 16, so h square will be 256. So we will have under root 12 to 8. On solving this under root, it will be 2 under root 307 centimeters. So in this way we can calculate the radius and slant height in this question. Now friends, let us discuss a very interesting question. The statement says a farmer connects a pipe of internal diameter 10 centimeters from a canal into a cylindrical tank in his field, which is 20 meters in diameter and 4 meter deep. So friends, we have a canal. Friends, a canal is a artificial made thin flow of water which is used for irrigation purposes and can also be used for household purposes after proper treatment. So we have connected water from this canal with the help of a pipe to a cylindrical tank. Now this pipe has diameter as 10 centimeter, that is radius will be 5 centimeters, whereas this cylindrical tank, which is 4 meter deep, is having diameter as 20 meters, that is radius is 10 meters. Now since these two are in meters, the dimensions, so let us convert first this radius into meter. It will be 5 by 100 meters, that is 1 by 20 meters. Let us denote these two dimensions by capital R and H, because we have denoted the pipe, the radius of this pipe, by small r. Now further the statement says if water flows through the pipe at rate of 6 km per hour, that is water is flowing at 6 km per hour, how much time will it take for the tank to be fully filled. So from this canal we are transporting this water into this cylindrical tank, and we need this tank to be fully filled. That is, we need the amount of water equal to the volume of this cylindrical tank, because this tank is to be fully filled. Now this is the flow of the water. So in meter per minute it will be 6000 over 60 meters per minute. Why we have converted it into meter per minute? Because we here have converted all the measurements into meters, and on calculation, on solving, we will get the flow as 100 meter per minute. Now friends, what does this flow signifies? In 1 minute, 100 meter of this pipe is covered. So let us take the n minutes is the time in which this cylindrical tank is fully filled. So we know that in 1 minute 100 meter of this pipe is being covered. So in n minutes we can say that n into 100 meters of this pipe is being covered, and since n minutes we have assumed is the time taken to fully fill the tank. Now in meters we have come to know the length of this pipe, that is length of the pipe which is being utilized in n minutes to have enough water to fully fill this tank. So in other words, we need n into 100 meters of length of this pipe if we have to fully fill this tank. So volume of water flowing through pipe in n minutes will be, since it is in a shape of a cylindrical pipe, so we can say volume is pi r square into h. We know radius of this pipe, which is 1 by 20 meters. So and h, that is height, or you can say length of the pipe. According to our given condition, we have come to the conclusion that n into 100 meter is the length required for this pipe if we need this tank to be fully filled in n minutes. So we can say the length here is n into 100. Now the amount of water which is flowing from this pipe in n minutes is this volume. The same volume will be used to fill this tank. That is, this volume is the similar or the volume equal to the volume of the complete tank. Now volume of complete tank is pi r square h, r and h in capitals. That is pi into 10 square, or 10 into 10 into 4. So now we can easily calculate the value of n, that is n minutes. It will be n is equal to 100 into 4 over 100 into 20 in numerator. So on solving we will get 4 into 4 into 100, that is n is 1600 minutes. So in 1600 minutes we can solve, or we can fully fill this tank according to the given dimensions. Now let us move on to another question. Now, in this question, we have water in a canal 4 meter wide and 3 meter deep, flowing with a speed of 12 km per hour. That is, we are having a canal. As said, canal is a long and artificially made thin stretch of water. Here it is 4 meter wide and 3 meters deep, whereas length of this canal is not mentioned. Water is flowing at 12 kilometers per hour. Now friends, this canal, how much area will it irrigate in 15 minutes if 0.6 meter of standing water is needed? So let us assume that this canal is used to irrigate a field where the height of standing water needed is 0.6 meters and the area we have to calculate. So let area be A. Now this A can be written as L into B, where this L is length and B is breadth. We need to calculate this area. Friends, what does this flow signifies? This rate of flow signifies that in 1 hour 12 km of length is covered by water. That is, if there is some water film assumed to be here, in 1 hour it will cover 12 kilometers and reach here with a distance of 12 kilometers. Similarly, for the previous water films or the preceding water films, that is, a volume here of water will reach in 1 hour a distance of 12 kilometers apart. So if in 1 hour the water covers a distance of 12 kilometers or the volume covers the distance of 12 kilometers, then in 60 minutes it will also cover 12 kilometers. So in 1 minute it will cover 12 by 60 kilometers, or 12 into 1000 over 60 meters. That is, in 15 minutes it will cover a length of 12 into 1000 over 60 into 15 meters. So we are utilizing 15 minutes from this canal. So in other words, we are utilizing a length of this much amount. So the volume of water flowing through canal in 15 minutes will be 3 meters into 4 meters into this much of length, that is 12 into 1000 into 15 over 60. Now for this field we have the depth or the height of the standing water to be 0.6 meters. So its volume will be, volume is length into breadth into height, and length into breadth is also area. So we can say volume is area into height. Thus volume of standing water needed in this field is A into 0.6 meters. All the dimensions are in meters, and this volume can be taken from this flow of water of 15 minutes, because we need to calculate the area which can be irrigated in 15 minutes. Thus we can say that if we connect the canal for 15 minutes to this field, then this much of water will be entered in the field also. That is, this much of volume will be occupied by this much of water. So area will be now calculated by simple mathematics, and it will be 3 into 4 into 12 into 1000 into 15 over 60 into 0.6, that is 6 to 10. So it will be area is equal to 60,000 meters square. So in 15 minutes this much of area can be irrigated if standing water of 0.6 meter height is needed. So friends, these were some questions on conversion of solid from one shape to another. Thanks friends for watching Edupedia Word videos.